Ciao friends! This video is an introduction to lookup value. Lookup value is quite a common function. Its purpose is that of searching in a table for one value and returning it. How does it work? Well, you need to provide lookup value first, the column you want to retrieve, and then a set of conditions that need to be satisfied in order to retrieve the column. Let's see an example. In the sales table, I have a calculated column, product unit price, and you see that I'm using lookup value. What I'm saying is that I want to retrieve the unit price from the product table where the product key is identical to the current value of sales product key. So the engine will open the product table, filter out all the rows where product key is not identical to sales product key, and then retrieve the unit price. It's very simple in its usage, and it's actually quite powerful because you can specify multiple conditions. So let's see a few more examples of usage of lookup value. The first one is retrieval of the exchange rate. Now, in my data model, I have a table that contains the daily exchange rates, and let's see the content of the table. The daily exchange rate, I'm not interested in the code, I want to see the content, has a date, a currency key, and the exchange rate. So in order to retrieve an exchange rate, I need the currency key and a date, and that will give me the exchange rate to US dollar of that date. So how did I do my calculated column to retrieve the exchange rate of one specific sale? First, I need the currency key. If I want the exchange rate to euro, I use lookup value to find in the currency table the value of the currency key where the code is euro. So I go from the string euro to the currency key, which is an integer that I will use to search in my exchange rate table. And then I retrieve the current date from the current row context, and finally I use again lookup value to search in the daily exchange rate for the rate where the currency key is identical to the currency key I computed earlier, and the date is the current date. This will find the exchange rate on one date and return it. You see that I'm using variables in order to store temporary calculations. This speeds up calculation and makes the code much more readable. Lookup value is actually more powerful than that. Indeed, whenever you use lookup value, you can use not only columns of the tables you are searching into, you can use the entire expanded table. You don't know what an expanded table is? Well, if that is the case, look at that link. There you will find a description of what expanded tables are, an important topic for any DAX developer. Anyway, the expanded table means that I can use any column of that table plus any column of related tables. So if you look at this code, I need to first retrieve the currency key from the currency table, searching for euro, and then I use this value here in the daily exchange rate. But what happens is that the daily exchange rate has a relationship with currency. So the expanded version of daily exchange rates includes currency. Therefore, I can use a shorter version of the same code where I use lookup value, and look what I'm doing. I'm retrieving the daily exchange rate, and I'm applying a filter on the currency code for euro. I don't need to grab the currency key. That happens automatically because of expanded table. So my two conditions are one on the same table I'm searching into and one on a related table. The code is simpler and it's actually even a bit faster. With that said, keep in mind, lookup value is powerful, but a lot of people use lookup value because they are used to VLOOKUP in Excel. DAX is different. DAX does not require you to use VLOOKUP to grab values. Relationships are much better. So whenever you work on a model, if you find that you are using a lot of lookup value, then it's likely you may need to review your model and create a few more relationships. Nevertheless, lookup value proves extremely useful whenever you want to search in the same table. For example, what if I want to compute the variation of price in the sales table? I sell products with different prices and I want to understand the difference between the previous price and the current price. To do that, I can rank my orders 1, 2, 3, 4, 5 by product, and then I compare the current price with the price of the same order in the previous ranking. What I need to do is search in the same table for a previous row. That cannot be accomplished through a relationship because I cannot create self-joins in DAX. But lookup value proves useful. Let me show you the code of the price variation, which is just using lookup value. It looks complex, but just because it's long, nothing more. See what I'm doing? I first grab the previous rank order, which is the current rank order minus 1. I take the product key and the current net price. All this is stored in variables. And then I use lookup value, searching for the net price where the rank order is the previous rank order, so not this one but the previous one, and the product key is the same as the current product key. This lookup value will return the price of the previous order, if any. In case there is no order, lookup value will return a blank, and in that case the coalish function will say, well, in case the result is blank, I will return you the sales net price so that the variation will be 0. The last step, computing the price variation, is just a simple subtraction of one value from another one. In such a case, lookup value proves invaluable because there's no other way to retrieve this previous price in an efficient way. Speaking about efficiency, keep in mind lookup value might slow down your code. If you find out that you need to use a lot of lookup values, again, it's worth spending a bit more time investigating on performances. But this is the topic of another video. Enjoy DAX!